worry about it.
Yeah,
When I went to Kyushu, we actually we flew into Fukuoka and then we drove all the way across down
yeah.
to, I'm gonna forget that, like the southernmost port city.
Kagoshima.
Um, yeah, I think so.
Yeah,
Like where there's that volcano in the middle of the bay, which is absolutely
yep,
insane.
yep,
And then we took a ferry. We actually put the car on a ferry and took a ferry
yep.
to Tanegashima, which is an island off the southern
That's right.
coast.
Yeah, yeah,
Yeah. And just, which is incredible. Felt like I was in Hawaii. I like went back in time, but I was in Hawaii or something, you know? It's
yeah,
such a strange
yeah.
and cool place. And then we went back and did a lap out to like Beppu and up to Mount Aso and like whatever. We kind of toured around the whole. And I
Yeah.
probably only
It,
spent 3 or 4 days in Fukuoka, but I would go.
there's a
I would
lot to
love to go
do.
back.
There's a lot to
Yeah.
do. I mean, so place that I wanted to go, but I didn't have chance to go. So Imari is one of them. Nagasaki. Just there's a lot to do in Kyushu for sure.
Yeah.
But I did go to
Uh,
all the. I did get the street food from Fukuoka, so I
oh
got
yeah.
that
I
sorted
mean,
out.
it's like
Yeah.
that's a required
Yeah. Exactly.
activity, I think. Um,
Yeah.
yeah, I was like into like making ramen and was I mean I'm still cook a lot of Japanese food, but at that point was super
Yeah.
into like,
Yeah.
understanding ramen culture. And yeah, Fukuoka is like wow, it's wild. You
Ni-
could
Nice.
get like I could have put on 20 or 30 pounds very quickly, you know, like you just eat and
Oh,
want to eat like the whole time.
I ate very well. I ate very well. So that's like I don't know how people stay lean over there, but I ate very
I know,
well.
yes, I know. It's like you have to have like a different metabolism.
Yeah,
Uh,
yeah, yeah.
um, okay, so the reason that I reached out, I don't know if I told you this. Maybe I did tell you this, but
Hmm.
the reason that I reached
Yeah,
out to you specifically, right, is because I was like, hey, people at TLON, I'm thinking about doing conversations with people in the broader community. Who should I talk to?
yeah.
And like immediately someone was like, talk to Jay. I was like, oh yeah, obviously that's it sort of
Oh,
this nice like nice that that's like uh
yeah.
anyway that yeah you're well known, you're internal
I-
celebrity.
I'm sort of a super fan. I think that's the reason why.
It's probably true. Yeah. And so, yeah, I was thinking, and then I was thinking, like, I'm like, okay, I was trying to remember where we met, and I was remembering, and I actually wonder whether you would
Yeah.
want to tell this story, so I'll ask you. But I remember
Oh yeah.
meeting you at an Urbit meetup, and you remember, like, because you were doing something very different at the time, which it
Yeah.
seemed like was kind of the seed of why you were interested in Urbit. Do you remember this?
Yeah, so I was in Smart Things actually. So Smart Things, like Samsung Smart Things
Right.
is a big huge company. They do Internet of Things, and I said, do you, I think I mentioned something like this. I said, Smart Things centrally handles like 3 billion messages a day. They probably have no reason to do that. They should just
Right.
you know, connect directly, with the IoT devices from like a home machine. So they're shipping all these things to do complex stuff. Really like you could just have a Urbit instance of a Urbit and then have like a comment be the IoT device and just handle it that way. Like that was
Right.
like one of the things that just popped up my mind.
Yeah. Well, I think that had always been it's fun. I think that conversation, in the back of that funny little office that we
Hmm.
had on 15th Street or whatever,
Hmm.
uh, I remember finding kind of amazing because it's something that I also like always thought about with Urbit, but I thought I I think I figured, well, like systems gonna have to be a lot more mature for someone to even like understand that this is important. And I think you
Hmm.
were the first person who was not like me or someone in the office basically who kind of independently saw that. And actually thinking about
Yeah.
it, the Talon person who was curious to have us chat
Uh-huh.
used to work on low power devices basically, and a lot of
Ah, there
his
you go.
interest was actually like he was like he had all this experience getting like things to work together over like
Yeah.
RF and
Yeah.
or just like really really super slim down. I don't even like understand them well. And I think of it basically like as a Raspberry Pi that's running on a battery or
Yeah.
something. But
Yeah.
like
Yeah.
uh, uh, these inconsistent networking environments and basically like having to build a lot of custom machinery to get them to reconnect and like handle
Yep.
being commonly offline, which is actually a harder case than the simple like whatever, like my heater, my TV,
Oh
something
yeah.
like that. I
yeah.
didn't realize it
I,
was Smart Things. The Smart Things app is terrible. It's so bad.
I
I don't
know.
use
I'm
it for other
sorry.
stuff,
I'm
but
sorry.
like,
I contributed to some of it. I was not in the mobile app development side, but I was in the
no, no, no.
farmer
I don't
side of
think,
things.
no, no. The thing that's really obvious actually is that
Yeah.
it's very poor. It does underline this like architectural problem, which is like I'm like
Yeah.
standing next to the thing that I want to control.
Oh yeah.
And the network latency, which is like I have to go talk to a server, whatever, like in
Yeah.
Korea, in order to talk to
Yeah.
the thing that I'm literally standing next to that I'm on the
Yeah,
same
that's
network
right.
with,
That's
is
right.
like,
That's right. You have
yeah,
to
it's
wait 2 seconds to
completely
turn on the
insane.
alliance. It's like, what the hell, you
Yeah,
know?
yeah. Uh, so yeah, that's definitely like I wonder how widespread that like impression is among people who work on IoT that like Urbit is a potential solution there because it's interesting how few I like
Well,
smart things like super widely distributed, but there's no one I don't as far out as I'm aware like outside of standards like Zigbee or something like there aren't really no one's
yeah.
really solving this
So the,
problem.
there was a uh what was the company's name that tried to make this was like the guy who made the creator of Android, and then he created
Oh
his own
yeah,
company, a
um,
phone company,
Andy Rubin.
Essential. Andy Rubin, right?
Yeah.
So before the whole like the other issue that forced the company to kind of go down under, like the idea was to like make the essential phone into one of the devices that interact with the smart home concept, and that they would have
Interesting.
something, yeah, they would have something similar to like Google Home or Home
Yeah.
like Hub that does a processing of complex logic that like if
Hmm.
the if this then that kind of thing on the home
Hmm.
machine. So some
Hmm.
people have thought about this because if they realize like why are you paying all these like money to run consumer uh, device logic on the cloud when you can just run it on the home device, right?
Yeah, yeah.
So yeah,
Well, it's yeah, I forgot about Essential actually, like, and I didn't understand it quite in that way, but that actually makes sense knowing, or
yeah,
like that connects to my memory of them. And
yeah,
it's interesting actually because it's true that if you could create the kind of proof of concept of even, I'm
hmm
looking at some like, I have like, I keep like small like music devices on my
hmm
desk all the time. It's my way of avoiding like, it's like a good way to procrastinate or whatever.
yeah,
Um,
yeah,
but like even just with something like this or whatever, right? Like
hmm
you could take anything, even something really fun, and if it's this is running
yep,
in Urbit and it's talking to something else that's running in Urbit, not only can you program these things, but the latency with which they could connect to one another could be very, very low. I mean, for music, actually not
yeah,
so good. Apple is too high latency for music, but
yep,
um, like overall, yeah, it is actually kind of the same thesis as a lot of the like application or like product development work that we do, where it's like the thesis is
yep,
this can provide a better user experience. Let's like prove that out, which kind of proves out the infrastructure as a whole. And I always thought of
yep,
like IoT as too big of a lift, but I bet you could do something there that like
yeah,
would be like kind of
yeah.
like
Of course.
smaller.
Yeah, so with the IoT, like the big issue isn't so much that it's a good idea, it's more like philosophical, I think. Like when you create
Yeah,
device drivers, you necessarily can't make it into a jet. And if it's not a jet,
yeah,
then like well you
yeah,
have to
that's not
build a
fast.
target specific, like device driver interaction with the host machine. But I mean, that aside, then after that, then you have an adapter inside, in Urbit, then you can write an app for it that interacts directly with like, whatever device drivers, right? So,
Yeah,
but it's
well, it'd
more
be fun to tear
philosophical, I think.
down. Right. So I always felt like the philosophical reason, like, hey, I don't want Nest to know anything about me or something,
Yeah,
right? Or I don't want Samsung. I'm like, yeah,
yeah,
that's true. I mean, I agree with that, but is that enough to actually, justify the engineering effort to like make that like just like it's Nest, but it doesn't spy on you? I'm like, like, that's an expensive undertaking. Like, is it
yeah,
worth
yeah,
it?
yeah.
But I wonder whether you could do like, yeah, a thermostat or like a simple, because like the other
Well,
thing you could do,
I mean,
I wonder, is like not actually jet it basically, right? So you have an
yeah,
Urbit running on a low power device, and that low power device has some external interface to a piece of hardware or whatever it might be. And you still have a host Unix instance that just has another process running, which is the thing that, is
yeah.
the IO pipe out.
Oh
and
yeah,
so you're like call
yeah.
out to that over even like,
Uh,
uh,
well, I mean, like you could even have a situation where you, I mean, like if you want to get really ugly with this, you can have a headless browser with a plugin, and then you
sure.
connect through the airlock or whatever. And it's kind of an ugly
Yeah,
solution,
yeah,
but
like your
you can do it
Urbit's
that
just
way.
talking HTTP to some other like
Yeah,
thing. Yeah.
yeah, yeah, yeah.
Okay, this is getting so
I'm sorry.
another no, 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 it's fine. The point of these conversations is not is there is no point
Yeah,
to them.
yeah,
They're just to
yeah.
uh but actually this came up in or we've been talking about like one of the for a long time like if you wanted to understand what Urbit is, like the best thing is
Hmm.
just to kind of read its source code, right? Which I think you're
Hmm.
someone who definitely came to understand Urbit mostly in that
Yep.
fashion. I wonder whether, but as Urbit grows and matures, my hope is obviously that you should be able to understand what Urbit is by using it, and you don't need to care at all about what Urbit is.
Yep.
Like it just feels good to
Right.
use it. Um, and I know as we talked about stuff overlap between Tassin and Urbit, and just as Urbit has
Hmm.
grown and you've got to work on other things, I'm curious how
Yep.
you explain Urbit to people because I think you have a specific kind of perspective on like why Urbit matters and how it impacts
Right.
like how it
Well,
potentially can be useful infrastructure for a lot of things.
right, right. I cover I so I explain it in a couple different ways. If like, privacy and data ownership matters more, then I make the case for like, well, Amazon auto, what is it? The auto suggest should not live in Amazon. It should live in your Urbit, and then you should just make a catalog call of items and then do the auto suggest in your home machine. So that's like one thing that I do. So going back to the whole like, well,
Wait, you
yeah, you
literally
should
do
own the
that, or are
data.
you saying you use that as a?
No, no, I'm saying yeah,
Okay,
I
okay,
use
that'd
that
be
as
amazing. Yeah,
that
yeah,
would be amazing. Well, if I have time to like sit
yeah, yeah.
down and
I
have a
understand.
little bit of like recreational programming, then I'll put that together. Um,
Yeah.
the second part, actually, the most important thing to me, and the way that I communicated with my peers, and they're mostly like, computer science folks or software developers. I just go straight to the jugular and I say well, deterministic computing. So if I were to compile something and run it in multiple target machine, they're always going to have some sort of different like nuances and differences, and how it handles numbers, strings, and all that stuff are always going to be different. And not just that, like there's a like version impermanence where like if I wrote something in like Python 2.7, I'll never be able to run it again.
Yeah.
I have to fix it. So there's like an ongoing cost of maintenance. So I just say, okay, if Java was intended to be, and I'm using a bad example with Java, but bear with me.
I
If
think
the
Java's a good example. I think it depends on how old they are.
Yeah,
If they're my
yeah,
age, then Java's a perfect. It's like if Java actually had satisfied its goals or something in the age of the
yeah,
cloud, I think that is a
yeah,
fine explanation. But
yeah,
go ahead.
yeah, yeah, exactly. So their selling point was, you know, uh, write once, run everywhere, right?
Yeah.
So I think the Urbit's tagline is really write once, run forever.
Yeah.
Meaning that
That's nice.
as long
Yeah.
as you write it once correctly, then there's no like uh, other than fixing bugs, if you wrote something that is functional and working, the underlying platform is going to be not going to be changing that much, and therefore you don't have to rewrite
Yeah.
the same thing over and over again to make sure that it works, the same way in the future. So like that's the way I explain it, and it does resonate well with like people that I've spoken to about like they don't want to write software forever. They want to do like higher function stuff, right?
Yeah.
So, I
Yeah.
mean,
They
there's
want to
a
go outside.
there's a yeah, I want to go outside. um, quality of life stuff,
Um,
right? Uh,
it's interesting actually because you make me think that part of what maybe we undersell, right, is like
mhm,
the architecture of Urbit in terms of like we say, okay, knock is a frozen function, and we can upgrade
mhm,
everything on top of that, which also means that we can, and this is still admittedly, something we're working on. You can like see
mhm,
this in the last OTA, which is like pretty good, but we
yep,
need better machinery around. But the
yep,
idea, right, is like there's one fixed foundation, and then everything else can be upgraded over the wire, which
Hmm.
is a very, yeah, it is the kind of, it's like, unlike Python 2.7, which you are going to have to go and
Hmm.
manually port that to Python 3. Like,
Yep.
ideally, we want to provide you a stack where we actually like provide the migration, like the migration is totally seamless. Like you wrote it, you sent it to your friends, their system
Yep.
continues to update, everything else continues to update. You never do anything else, and like that's
Yep.
still a
Yep.
runnable thing.
Yep.
Not perfect. There are cases where that like system APIs will change, and like you will probably have to do like forward. You'll have to forward port
Well,
your work, but we're like
yeah.
committed to making it possible that you could forward port it, right? And that it should
Correct.
be as
Correct.
trivial as possible, um,
Well,
which is
I
different.
mean, like here's the best example is that like the people who are still on uh, Zeus 420 were able to communicate with Zeus 418
Yeah,
people.
yeah, yeah,
So I mean,
yeah,
that's like one of the working example already. And
yeah,
like the second salient point that I always make is so Urbit has a lot of like networking and distributed programming primitives that
yeah,
if you line up the numbers of code lines of code side by side, then like what you would have to do with all the stuff that is in the Linux programming API, and or you have to pick some library on top of it, like or to ensure item potency or all that stuff, right? Like you have to like go out there into the wilderness literally to pick out these things, as opposed to okay, the operating system itself already has these things built in. There are some
yeah,
basic guarantees, so on and so forth.
yeah, yeah. Yeah, we don't do a good job, I think, of articulating this idea. We used to talk about it
Yeah.
kind of as like the in like the world of building centralized applications, you have like a very thick stack, right? So it's like
Boy,
in
yeah.
order to make like yeah, it's like horrifying for anyone who's aware
Yeah.
of it. Most people aren't aware of it, but like you have a Unix box with an internet connection and then just like this tower of dependencies. It's incredibly hard to manage. It's like entire departments of, there are like thousands of people in the
Yep.
world who have to manage that thicket of dependencies. And then your
Oh yeah.
application is still actually, whatever, like the front end and the business logic. I mean, it's not that complicated by comparison. Um, and Urbit tries to take that whole stack and just say, look, that's a system. Actually, it's a very complex, or it's a
Yeah.
very compact and quite like refined system. So the programmer never has to manage that, and so you can just focus on that like tiny thing on the top. Um,
Yeah. But
yeah, it's true that it's a huge benefit, but you live in a different world, obviously, or like
well,
Urbit is
well,
not.
well, I, well, I mean, but at the same time, so programmer still has to determine things like, okay, do I want to use 0MQ or Kafka or whatever else, like, different kind
Right.
of like messaging, library to ensure that messages are handled a certain way. And like configuration of which and like testing of which becomes a just tremendously draining exercise. It's
Yeah,
like I don't feel like I've learned anything by doing it, as opposed to
yeah. I'm always surprised by
anyway,
people
yeah.
who actually like doing that stuff. I mean,
Uh, I
I
don't like
definitely,
doing
in
it.
some ways, the story of me finding Urbit to work on was like I hit a point of building conventional software where I was just like, I'm never doing this again. Like
I don't
I
I
can't do this anymore. Yeah,
Yeah. I can
it's
I don't
extremely
enjoy it.
frustrating.
I don't enjoy it.
But you are doing it. So,
I have to.
uh, I mean, well, you're doing something interesting, and it's probably worth it. Basically, is maybe
Mhm.
another way to think about it, right?
Yeah,
So,
that's true. That's
uh,
true.
yeah, maybe another thing to kind of dig into, which is related,
Hmm.
although in a different way, right? So we talked for a while. Maybe it's good to start with just kind of like, well, Tassin now has split into two different things, right? So you're
Hmm.
working on two different things, and we'd have had a kind of over the years ongoing conversation about how Urbit could be useful for
Yep.
Tassin, which actually I think encapsulates a kind of categorical use case of Urbit, which is the kind of like, look, just build whatever software you want. It doesn't matter what jurisdiction you're in or what,
Yep.
where your customers are, and you don't want to care for their data. So you want to just be able to
Right.
provide them software, let them do whatever they
Yep.
want. And that's kind
Yep.
of like a choke point use case. It's very difficult to handle, although you guys are figuring out how to handle it. But anyway, so it's probably worth starting with the like, and actually,
Hmm.
I mean, I remember what Tassin is, but you can refresh
Yep.
me on where what
Yep.
the current Tassin, and then there's a few other things that you guys are working
Oh,
on.
yeah, yeah, of course. So thank you. I, so Passion was born out of my frustration that I had to put my money into some exchange if I wanted speed. So like the
Yep.
Coinbases of the world and whatever, right? Finances of the world. And they have control over my money and they can, for whatever reason, freeze it, prevent access or whatever it is. They
Yep.
can even come up with an excuse like, oh, you know what, like system is too busy, we can't log you in.
Yeah. Yeah.
While like API power users still have access and they're still trading. And so like I'm like I can't even sell because I can't even log in. Um, so like it's like a degree of control that one doesn't have. And I was on the plane and I said, okay, what would I like? What kind of exchange would I like to trade? Because at that point, 2019, June, uh, like I traded everything under the sun, like equity, options, futures, and everything up to that point. Like, because I've been trading since 2006, and I also traded crypto. Wasn't very good at it, but I,
But wait,
I
just for actually for context, I'm
yeah,
realizing either I don't remember or don't know, but your
yeah,
background is technical, right? Like your
yeah.
interest is in markets, but like your background is technical,
Right.
right?
So I went to Georgia Tech and got a master's degree in aerospace engineering. So
Okay,
and
I did
like
not know that.
specialized
That's
in
crazy. Yeah.
no, yeah, but it was a hard engineering and specialized in helicopters actually. So like things like you have a helicopter blade rotating and then it sheds vortices and I need to figure out like air elastic effect of that onto the following following blade, that
Well,
sort of thing.
yeah.
And then what happens if it's all moving and impact on the fuselage and all that stuff. And I did that for
Right.
like 9.5 years. And I'm like, okay, I did my time.
Yeah.
Uh,
Yeah.
and it's a very small community. I go to conferences and we meet the same person over and over again. Hello, sir, how are you doing this
Yeah.
year? And then I did, and then I did e-commerce. Like I said done, and then I did the e-commerce thing. Then I did the IoT thing, and then I did the payment processing and crypto. So yeah, so kind of hard engineering
I mean,
to
it's great. Yeah.
software. Um, so like one of the things that I did a lot of software writing in while I was doing helicopter stuff was writing physics software essentially, like running these things in real time and then figuring out, okay,
Yeah.
make sure that I can either guarantee real time or I can have um, sufficient fidelity, but I can't guarantee both. Um, that aside, uh, actually, there's a salient point there for
Yeah.
exchanges
No,
as
that
well.
makes
So
sense.
yeah,
Yeah.
yeah,
No, it makes sense because you can't if you need the throughput of real time,
yeah,
you have to figure out what your most like what your kind of like computable output can be at that rate or
yeah.
like at the rate that can be computed in real time. It can't be
That's right.
everything
That's right.
because that would take too long. Yeah.
Yeah.
Um,
Uh, like
Interesting.
basically things like your model fidelity is one that suffers if you want to do a lot of
Hmm.
different stuff at the same time. Um, as opposed to if it's just like yeah, I don't care if it runs for like 9 hours to simulate 30 minutes.
Yeah.
Just
Yeah.
just do
Yeah.
it.
Yeah.
um, and so when I started like thinking about this in 2019. I said, okay, fine. Then why don't I design a DEX? But then I also didn't like DEXs because it just takes forever to like submit the
Yeah.
order, and then there's a like finite like or there's a discrete like there's a minimal time that I have to wait, like which is a block time, like 13
Yeah.
seconds or whatever it is. It's gonna be reduced
Yeah.
after merge, but whatever. And but that still means that like even if it's 11 seconds or even 400 milliseconds on in like Serum's case, we're updating the state at an incredibly low speed frequency at low, very incredibly low
Yeah.
frequency that
Yeah.
uh, updating updating market conditions is just not worth it. Like,
Yeah.
and if one can't guarantee state update at a microsecond level, then the um, opportunity cost for cancellation uh, becomes higher and higher. So meaning like
Yeah.
you're parking money for 400 milliseconds essentially, as opposed to
Yeah.
16 microseconds. So I
Right.
thought about all this and said, okay, well then what's the solution? Well, the solution is let's take this is one of the few places where hybrid approach is compromise is okay, and that is
Yeah.
that let's take uh, let's use centralization where centralization is maximally beneficial, which is like updating order book.
Yeah.
But let's use decentralization where security is most important or custody is most important, where
Yeah.
it's settlement. And
Yeah.
settlement doesn't have to happen like at every trade. It just has to be
Yeah.
the aggregate amount that gets settled at some point. And what that
Yeah.
also solves is like principal agent problem, where
Yeah.
the operator of the exchange is not incentivized to like run away with someone's money if they don't have custody of the fund to begin with. And then
Yeah.
two, the then what ends up happening also is that then the exchanges can focus on the experience of trade and improve the user experience rather than like focus on things like financial surveillance or whatever else might be. So
Mhm.
that's sort of like when I thought about it. Okay, then let's build that. um, of course, like you
But
already know this
the
and I
basic
know this.
idea,
Yeah,
I already, yeah, I now
yeah,
this part I definitely like, but the basic
yeah,
idea being just to like try and crystallize it, make sure I understand it really
yeah.
like, is that you could create an order book especially with decentralized systems where that order
Hmm.
book is pre-committed like signed transactions, right? So the
Hmm.
order book, all of those orders can be executed in the same way that they would be on a DEX, but you do that in a centralized fashion. So you can have very high throughput, like just the time to settle or the time to deciding which order to submit to a chain can be very, very low.
Yeah.
But then those orders eventually just get sent to a chain. Like the whoever is running that book decides which ones to settle and then they go out. Or
Well,
yeah, what am I
not
missing?
quite, not quite. So order book is just composed of um, orders, like standing orders. Like you want to, let's say that you want to sell Bitcoin at $40,000, right? And then
Yeah,
what that is an instruction to sell that amount of Bitcoin at $40,000, so that that sits on the ask side of the book. And then
yeah,
I say, hey, I want to buy Bitcoin at $28,000, 10 of
yeah,
them. Then that sits on the bid side of the book. And as soon as
yeah,
someone puts in more orders that like intersect with it, then that becomes a trade, and then that trade gets executed. And at the end of
hmm,
that, those executed trades that create an obligation of settlement and
hmm.
clearance of the fund. Now, doing all of that on chain and doing state update, as you already know, is very
Yeah, it's
expensive
impossible.
and time consuming, right? So like the updating the order book also has to take into account, like, let's say if I cancel the order, then I have to pull that order out in a timely fashion so
Hmm.
that no one can just jump in front of it or like front run my cancellation of order and try to get it executed. So like
Hmm.
the what's called a fair ordering problem is extremely important in where we
Right.
have what's called a non-discretionary trading environment like exchanges, where order book based system basically means that like you have to have a linear history that is
Hmm.
absolutely
Hmm.
clear, which means that you can't have like any kind of non-determinism there, right?
Hmm.
Um, and then secondly, the not only do you have to guarantee that the ordering is correct, but two, it has to run very fast because there is no parallelism that can be done.
Right.
So
It's a
what I mean
linear.
is
If it
that
doesn't execute
that
linearly, it's not correct. Yeah.
that's right. That's right. I mean, like, so there are concepts like vector clocks where you can sort of think
Yeah.
about like dependency graph, and if it's far enough in the dependency or it's not dependent on one another, then yeah, you could probably parallelize it. But like, I'm not a mathematician, and
Too
most of the
complicated. Yeah.
exchanges, like, yeah, most of the exchanges like Nasdaq and Island and Arca, what they do is like they just have a very fast machine and an infinite
Yeah.
memory, and,
Yeah. Yeah.
and they just run it. They just run a single-threaded operation. Um,
Yeah.
but where that works with Urbit is the following. Like let's say that there's an exchange. Someone's running an exchange on a on a star, and there's some sort of bridge to faster subsystem that basically accepts orders, signed orders, and then spits out batched trades.
Yeah.
What I envision is that Urbit could serve as a way to disseminate those information to constituent planets, and then say, hey, like instead of using WebSockets, you can just say, you can just use Urbit to
Yeah.
number one, use it as a messaging system, but number two, each planet could host its own trading terminal, right? Like the
Hmm.
front end should not be the front end should not be served by like so here's a value proposition, right? If Coinbase is having trouble handling 20,000 simultaneous login, perhaps they should not have an
Hmm.
account system.
Yeah, 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 right,
And
right. So you're
yeah,
saying you host your own interface,
yep,
like that is just pulling data
yep,
over Urbit's own network from an
yep,
order book that is also
yep,
on another on a it's on a star or something to that
yep,
effect.
yep,
Um, and then you are signing and sending your orders over
yep,
Urbit.
yep,
And so that signing and sending is also being handled by your planet, but the actual, yeah, the sort of deterministic execution of the order book is
yep,
is done by the star, who could even
yeah,
provide proofs of their deterministic execution. Like they could just be like,
yep.
showing their knock formulas or something like that.
Exactly, exactly. So like, it's very similar to like, or alternatively, you can have something similar to like TLS notary type of system, where there is a like, um, there's a middle entity that is not exchange or the trader that the traffic of the request goes through. That like
Hmm.
basically just like tags the request and then response, and that way we know
Hmm.
that it's been accepted by the intended target if that's
Hmm.
something that needs to be done, like as an additional security. Now, like, but then there's like additional value that each client can have, which is, well, in a non-custodial exchange, you need to have a settlement system that is separated from an exchange. So what I mean by that is, well,
Yeah.
if you're committing fund to be traded, you have to lock it away somehow. And then when you're unlocking it, you're basically like paying obligations or receiving funds. And in order
Hmm.
to facilitate that, have third party record all of the trades that are happening, executed trades, record it, in time ordered fashion, calculate the obligation when someone asks for it, and then have different data providers of these sort come together and basically just simple consensus and say, hey, like I know Alice owes Bob 1 Bitcoin, and Bob
Yep.
owes Alice 10 ETH or whatever, and uh,
Yep.
having that obligation be recorded by a third party would mean that exchange no longer has to like store enormous sums of data, and then the data providers can also earn a little bit by providing the settlement data. And so it's like we're
Oh.
now it yeah, yeah,
Oh, that's interesting. So, right. So the order book is handled by one party, and then the
yep,
settlement is handled by is in some
everyone,
multi-party, like, yeah.
yep,
But in order to even trade in the system, yeah, you do have to lock up funds, basically. This
yep,
is the way many dexes work, I think, right? Because
yeah, yeah,
which makes sense, like
right. So like
because you
the
can't be
so
gated
the
on. Well, yeah.
That's right. That's
Go
right.
ahead.
Because like you don't want to do double spending, right? Like so you can't just say, "Hey, I have $10,000," and then, "Oh, by the
Yeah.
way, I moved it already," and then I traded ten
Yeah.
thousand.
Yeah.
You can't do that. But yeah, so like there's sort of like the mutual covenant that people can enter in by like in Ethereum, in EVM, smart contract that basically locks the fund until the settlement obligation is has been well, until the settlement has been requested and processed, and then there's a consensus that's reached that releases that fund or a portion of the fund,
Right.
yeah, and so on and so forth. Now, the benefit of that, finally, I'm so sorry,
Yeah.
one more thing.
No, no, no,
A
no, no.
benefit,
I mean, we haven't talked about this in a little while actually, so it's helpful
yeah,
and yeah, it's good. Go ahead.
yeah. So benefit of that is that settlement is entirely peer-to-peer, and so the exchange itself is not a money transmitter.
Right. No, I understand that.
Yeah,
Yeah.
which means that there's a reduced KYC and AML
Yeah,
requirement,
yeah,
if
yeah.
any.
But you still have, I mean, but
It
yeah,
depends
it's a
on how
wild.
extent it depends on how extensive. It depends on whether the powers that be wants to expand the definition of financial institution.
Yeah, yeah, no, that part I understand,
Yeah,
but I think what's
yeah.
interesting is like, but you guys do face, and I don't know if you want to get into this, but I mean, part of
Hmm.
there is still, some regulatory risk, and many DEXs
Yes.
face the same risk, right? Which is like,
Yep.
which actually I don't understand deeply, and I don't know how much you want to get into it because I know it is like, it's the kind of thing that
Hmm.
you want to think carefully about, or I know you guys think carefully about. Um,
Hmm.
but is that part of, well, actually, maybe my question is more like, because you guys are move, I mean, this thing is, I actually don't know if it's how far along you are. I think it's at least close to working, if not already working, right?
Yep.
Like,
Yep. You'll
yeah,
you'll
yeah,
see you'll see an alpha demo in like month and a half essentially.
that's exciting. That's cool.
Yeah.
Um,
Yeah.
and so, but you're obviously, at least as far as I know, not actually using Urbit for this, although doing it over Urbit would have some, like, what's the difference between the existing system that you have, uh, which I'm imagining
Right.
is just
Yeah.
you have a centralized, or you have a single order book, and then you have basically this ability to sort of validate settlement, and other people can run
Yep.
those kind of basically validators, and then
Yep.
anyone who's a client is basically just using a wallet in a browser. Is that right?
Right. Yep. So what's the difference? So difference is that now that currently we have to write a WebSocket streamer service that these settlement data oracles that are written in Go have to, a compiled binary has to then connect to the WebSocket host and read every traffic of trades and then use it as a basis for constructing these like obligations that
Yeah.
the obligation data to be served later. Now, messages are not guaranteed to be delivered. and
Oh, okay.
and
Yeah, yeah,
there's
yeah.
a
Okay,
lot of
that's a
like
serious.
buffering.
Yeah.
Yeah, I mean, so that's a serious problem, right? Like, so the SDOs still have to like get buffer data from previous like source or snapshot of the data and then reconstruct the
Yeah.
event. And there's no like sort of subscription based with a relatively long buffer that allows for relatively unavailable network for these like data
Right.
providers to like reconstruct the events. And so Urbit could immediately solve that. I mean, that's like that's a
Right.
no-brainer.
Right. Right.
I
Right.
don't even have to write the WebSocket stuff anymore. I hate doing that. I remember.
Well, you have a, that's like a, because wait, but the other part of this, you're basically saying like, how do these, what do you call them? Settlement. How do these settlement oracles like
Yeah,
become eventually consistent, right? Because they have to become eventually consistent, and
yeah.
right, is that right? Way to
Well,
think about it, and then,
yeah, yeah.
but you don't know, but one may fall out of, yeah, one may simply become disconnected from the
Yeah.
network, or it may become disconnected from the order book, and so once it
How do we know?
reconnects, how
Yeah,
does it catch up, and how do you know? Um,
yeah.
and
So what?
the other
So
question I
we
have though is,
we
how do you
yeah.
incentivize them to do that? They get rewarded in some token, basically.
Yeah, yeah. So we know that, well, at least internally to a operator of SDO or an SDO software itself should know it's like out of sync by basically looking at the sequence number of the events, like, similar
Yeah,
to
sure.
how Orbit messages are handled. So like if they
Yeah,
have like record of like handling everything up to message 200 and like all of a sudden the next message is 220, then they know they're out of sync. Like
yeah,
how to
yeah.
prove that is like the
But they're
outgoing
incentivized to
messages.
do and the reason they
Hmm.
would even want to reconnect is because they're incentivized to basically validate the settlement transactions or something like that,
Yeah,
right? So
that's
it's
right.
like
That's right.
that,
They
yeah,
have to have a complete history in order to serve the need of the traders to settle. And if they miss that 19 message, then they can't. So
yep,
now
got it.
that
Okay,
that's how we
yeah,
incentivize them to like reconnect. And then how we verify that that's true is that all signed orders that go into order book when they get matched, the exchange signs it with its key, and then that payload goes out along with the message sort of like the nonce essentially. And then what we also do is we sequentially hash every message that go out. And so like if like no one can like there has to be some point at which that if someone is missing a chunk of the data, it's going to become very inconsistent right afterwards. So
right,
like, but I don't want to have to
right,
write that,
right.
right?
Yeah, 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 right. Like you're just saying you're doing a lot of work to basically ensure exactly once delivery of messages and to
Correct.
handle the reconnect logic and basically
Yeah.
like sort of like resubscribe logic, which is very much a big
Yeah.
part of how Orbit networking works and why
Yep.
you can, yeah, like write a very simple Gall app that just like, that connects to a bunch of other nodes on the network and it can be a few hundred lines of code or less
That's
and
right.
still like
That's
keep
right.
its state intact. Yeah, no, I mean, it's an incredible,
That that's
we used to
precisely
talk
it.
about it
That's
more,
the,
to be honest. Yeah.
I know, and
Yeah.
and then I was like, and I think I remember like, okay, well, we just need high throughput, and I think that's where kind of like, yeah, because you have to
Right.
guarantee a lot of
It's not.
things, and then yeah,
Yeah.
yeah,
I mean, Urbit has gotten
um,
faster, but it's for like sub-second trading activity that's not really that we don't operate there quite
right,
yet.
right.
Um,
But even if
it's
even
it'd
if
be
it
interesting
doesn't
to
get
come up
there,
with a
yeah,
well, it's almost like you're making me think. So the thing I mean is that we used to pitch this, like we used to always say, like,
yeah,
hey, Urbit is a system that has exactly once message delivery. Like no one thought this was possible. Like Urbit makes this possible. Actually, through some very
yeah,
dumb and simple, it like just simplifies the problem a lot, right? And just says
yep,
everything has a sequence number, everything is signed, and reconnect if you didn't see that sequence number.
yep,
Um, so we handle that at the networking layer, and then at the application layer, we make it very easy for you to just do like like
yep,
to your subscription logic is pretty simple. Actually, it'll get a lot simpler after we have a project later
yeah,
this year to make that even simpler. Um,
yeah,
but it's true that this is a category of decentralized application that I do think is really both like really important and there are a lot of them where basically,
yeah,
yeah, you want to have a lot of nodes that are sharing data relatively quickly. And all those nodes keep the same data set, but it's on
yep,
a blockchain. So I think everyone's
yep,
like, oh, that's a blockchain. I'm like, it's not actually a blockchain because
yeah,
like, how are you going to secure that blockchain? Like, how, what are you going to like, oh, I mean, cool, Cosmos is cool. Like Oakbar is cool, well, that's different. But like all these blockchain in a box things, like they're kind of cool, but you have to spin it up, right? So it just
yep,
sort of doesn't actually make sense, even if you're getting, settlement times on whatever it might be that are really, really quick. I
yeah.
wonder, I guess this is what people think like Solana or Avalanche is for or something, right? But I don't know. I've never
But I mean,
really, that
but
doesn't make sense
yeah,
to me.
but again, like Solana or Avalanche, like either the argument is that, oh, okay, it's like lower fees, or better finality, or quicker finality, or faster block time. But like, if you have a system like anything similar to Ethereum, then you're gonna suffer with a lot of orphan blocks, and maybe there's a solution to it. But it's like at the end of the day, like anything blockchain is basically like I liken it to a funnel to guarantee um, ordering of events without
Yeah,
resorting to like centralization, right? Like you're basically
yeah,
using math to like, you know, math to ensure that there's only one solution at any given time and using that as a basis for lining of events. So necessarily
yeah.
blockchain is slow, necessarily. Um,
Maybe the basic insight though, which I do think is
yeah,
partially the insight that like Cosmos or Polkadot is on about, is that and this is I think what you're kind of describing, right? Which is saying, hey, look, the settlement oracles here, they
mhm,
need to share, they need to have one single like sort like idea of what is true, right? There is one
yep,
ordered, like there's one order
events,
of how they arrive at the final state that are like, and that
yep,
state is consistent among all these nodes. The
yep,
problem, maybe another way to articulate it, and the thing that always grates me is like using a blockchain for that. If you're
hmm,
actually saying, I'm just going to inject my state into a very large global state, right? And that
yep,
very large global state may contain a bunch of other garbage that I don't care about, but I'm just going to happen to like pay to shim my state into that global state.
yeah, yeah. It's very
Yeah.
frustrating.
Well, and so if you need the security guarantees, like if you need the security provided by some proof of work, some chains, like you need something about the security guarantees of that chain. Okay, maybe it's
Yeah,
worth that trade-off is worth it. But there are a lot of cases
yeah,
where that's not true, and where what you want is something, and I think it almost like needs a name, which is basically like it is just this ring of trusted nodes that have a
yep,
singly consistent state and they bring their own
yep,
security. So it's like you just validate who they are based on they own some key or whatever.
yep,
Um,
yep.
it needs a different name. It's like not a blockchain. I'm not sure. Maybe it already has a name. Uh,
Oh, yeah. I hesitate to do it. I mean, why don't we just call it urban and just be done with it, right?
well, yeah, it is Urbit, but there are things. I
Yeah,
mean, I've been talking to Tim a lot about Ukbars in general, and so like
yeah.
Ukbar and Urbit like make it's like a specific category of decentralized system, I think. And
Hmm.
Urbit does part of it. If you want real consensus, you want something like Ukbar, you want a bolt on. Like Urbit kind
Yeah,
of makes consensus possible. We don't necessarily do consensus. Like a Gall app isn't. There's no consensus. Like you can just kind of enforce it in the rules, but if you want it, whatever, it's like I don't know.
Hmm.
Anyway, it's interesting to think about. I still think it needs a name.
Yeah.
People love names, but I guess we could just call it Urbit.
I
uh,
mean, I mean,
I
I
just
was
mean as like the
now.
category is a category of thing, right? I think I'm just realizing that there are so many times where people pitch me on, or I hear about uses of a blockchain, right, that are this, where and the thing that I always get stuck on is I'm like, why are you just using this global state machine for this? Like, you're just trying to be this. You have this very small
Yeah.
amount of state that doesn't even need the security of the chain. Like, why are you doing that? And it's like people don't have a definition of what that is, right? Which is like, it is like just like social computing. You just want to compute together and you want to have like it be high
Uh,
trust in some fashion.
call it vector protocol. I mean, like I'm not making it up. I mean, like if you think
Yeah.
of, so if you look up like vector clock, they basically say
Yeah.
things like, there's related events, and if they're not related, you don't
Yeah.
really care about it, right? So it's kind of like
Right. Yeah.
it takes advantage of like causal relationship. So I don't know, maybe it's like
I mean, yeah, our
causal network
networking
or
is kind
something.
of like a
Yeah,
vector clock almost. Yeah.
yeah,
That's like,
yeah.
hmm.
Causal
Anyway,
network,
this is
causal
cool.
system. I don't know. Yeah, something like that. I don't know.
This is the point of these conversations, basically, is to
Yeah, yeah. I enjoy
at
it.
least get into some. Yeah, me too.
I, I,
I mean, this is the kind
I
of
had
stuff
to.
that I would like otherwise have this conversation with you like at an urban meetup in a credit
Yeah.
room or something. I feel like
I was just wrestling with Kafka, and I'm like, why is this set up this way? Like, oh my God. I mean, but this is a
it's a
relatively
crazy system.
successful system. It's a relatively
Yeah.
successful system compared to others, and like I'm still like I don't want to use it, but whatever.
I mean, it's such a. I mean, there's another thing like that's so like DevOps, like dependent, every dependency is a liability is like the way I think about it,
Yeah,
you know? And so,
yeah,
and so a dependency you don't understand, and you can think about the cost of that liability just in terms of the
yeah.
number of lines of code in that dependency. Like Kafka's a fucking huge system, and
Well,
so that
not
is a huge
yeah,
liability. Uh,
not just that. There's like if you configure one thing and it behaves one way, if you configure it differently, it behaves different way. Like meaning like, yeah, sure, you want flexibility in terms of like what the user might want to do, but like at the same time, I just want something that's a lot simpler and something that I don't have to worry about whether the if I miss a configuration line item, that it just completely breaks my system, right? So meaning that
yeah,
if
yeah,
I run this in production, then I have to be like extra vigilant about like
yeah,
every
yeah,
line of
yeah,
you know configuration. Like it's just exhausting.
yeah, yeah. We have this compounding effect too because they all depend on
Yeah,
each other, and so yeah, there may
that's right.
be like every RPC or every API call, like every like can break something, which in turn can
Yeah,
depend on some configuration parameter. And
yeah.
I mean, it's I just look at like maybe the statistic I should really have in my head is like, yeah, like what's the size of like the DevOps team at Slack, Dropbox, Discord, Twitter, whatever. Like it's like what
Oh
is the
boy,
cost of DevOps, right? It's
can
huge, like it's
cost,
huge
cost
cost.
enormous, enormous. Can I just tell you something? While I was working at big huge company with big huge DevOps team, I won't say which one. Um, I was looking at the company Slack, and someone says something's broken. Someone please look into it. I'm like, well, one, like, and then like the developer who did it is just not even available. Like, even though like the concept is, oh, you know what, like DevOps is
Yeah,
you get developer involved and they're on call. Number one, like the concept that you should have developer on call is
yeah, yeah,
terrible. Then you can't. Yeah, I just can't even sleep. Like I get a phone call
yeah,
from like someone saying that this is an alert from pager duty or something like that. I'm like
yeah, yeah.
my heartbeat drops. Not just that, and finally because no one was available, there were a lot of unhappy customers, and then
Right.
like not just that, like the DevOps guy finally comes up like relatively quickly, and he says, "I'm looking into this," and someone says, "Thank you very much," and then the DevOps guy says, "I know this is my life now."
Right, right. It's like the human tragedy. The real
I
DevOps
know,
tragedy is the human tragedy.
I know it
That's not what
is
I
because
thought
I
you were
felt
gonna say.
bad for that guy. I'm looking at it from here, and the
Yeah, yeah,
guy was in Asia. Let's just say that.
yeah, 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 yeah,
And this was like late, like like 3 a.m. in Asia, or some,
yeah, yeah,
or
yeah.
something to that effect. And it's like,
I mean, there are
Oh
always
my
things that are
gosh.
gonna be mission critical that people are gonna, commit to.
Sure.
Someone, patches an oil pipeline or something, but
Yeah, yeah, yeah.
it's funny because the other thing I think about is like, yeah, I often try and explain, it's like, it's hard for people to understand. It's like shipping an Urbit app is like sending someone a CD-ROM, So
Yep.
like, if you send it out and it works, I mean, with the benefit of you can live update it, but if you send it out and it works, like you don't have this situation, So yeah, you're kind of like your bug fixing timeline or whatever. You're like your just
Yep.
working process is so much more humane because like I mean, and we think about this and can still get a lot better at it, but we think about it with
Yep.
OTAs where it's like you test something up until the point of you release it, and then you want to be available for, whatever, 12, 24 hours after you release it. But
Yep.
like 12, 24 hours after you release it, like you're going to see everything that you're going to see.
Yeah.
And sure, it's important to be continuously updating stuff, and you can force yourself into a horrific DevOps situation. But when you're just like basically sending someone, a binary or whatever, and
Yeah.
they're using it, like it's different than saying, hey, everybody just update all the time, and we'll like force people to be awake all the time. I don't know,
Oh
maybe
no.
big, maybe it's inevitable. I guess it's not that different than App Store style stuff too, though. Like, I
Yeah,
don't know.
I mean,
Yeah.
I think what it is this, that everybody's updating everything. All apps have, all microservices have codependencies due to like changes in
Right.
schema of data, whatever. But like, so none of the microservices that are out or like service architecture, well, they do better in bigger companies. They do poorly
Yeah.
in smaller companies, and they don't even worry about it in like startups, right? And
Yeah. Yeah.
uh, so then everything breaks all the time, as opposed to
Yeah.
like, let's say that we have some guarantees, like even just handling like message consistency, or even like having a very strong backward compatibility. Like, yeah, sure, I wasn't able to update like, Zeus for like, 3 months,
Right.
but I didn't care because it was still
Right.
working.
Right. Right.
You
That's
know?
yeah. That is a benefit. Yeah, it's funny. Uh,
Yeah. And, and
the
like, sure,
backwards
like it was
compatibility
just,
thing is cool.
yeah, yeah. That's a huge one. Like I think people don't realize how big of a benefit that is. Um,
It'd be
and
even cooler if
like,
you could roll
yeah,
back, right? So like being able to just say, oh,
right,
actually, like I tried this one, does it work? Let me just like use the old version, which is very desktop
yeah,
software. It's like you're like, oh, I installed a new Photoshop, it doesn't work very well. I'll just use the old
yeah,
one.
yeah. I mean, there's a lot going for it. I think like that just needs to be like communicated side by side to like bunch of devs and say, hey, you could have written this 2,000 line code, or you do it with with a
Yeah,
50
yeah, yeah,
line hoon,
yeah,
right?
yeah, yeah. I mean, this is like Josh thinks about this a lot. This is sort of like Urbit.org will get a major refresh
Oh,
into the
I'm
fall.
sure. Yeah.
And then yeah, a lot of what we've been thinking about is how to hone in on these like what are these categories of like applications that can be built on Urbit, whether they're like landscape apps or they're even
Mhm.
more on the IoT level,
Yeah.
that where we have a huge advantage.
More
And interesting
simply,
actually.
more simply. I'm sorry, go ahead.
What, oh, you mean just like more simply like our advantage is simplicity?
Well, more simply, like I am kind of decision maker in my company, kind of. So
Yeah,
we can jump right into Urbit as a corporate chat, like just like
right,
tomorrow if I wanted to, right? But like
right.
there are some like productivity side of things, like message notification, webhooks, and
Oh,
things like
right.
that. Like yeah. But like once
Uh,
that's solved, like it has a lot of like lot of promise because I don't want to use Slack. I mean, like I don't want to
right.
pay Slack.
Yeah, these are two. So I mean, TLON
Yeah,
definitely works on the just product quality side such that, yeah, you would use
yeah,
Tassin as your default sort of collaboration suite. And ideally,
yeah,
Landscape gets good enough that not only it hits the baseline where it feels good out of the
yeah,
box, but it's legible enough that you can go and customize it however you want to relatively quickly.
yep,
On the sort of Urbit as a platform side, I think I'm thinking about sort of like, what is it that, like, how do you just incisively demonstrate like the power of the system in specific categories? So like,
yeah.
um, what is it that, that just like, what is it that Urbit can do that like nothing else can do? And can you give like three examples of things where you're sort of like very much categorically better?
Yeah,
Um,
yeah,
and anyway, we've been talking about it a lot. I think there's, we'll see what we can do by the fall, but it seems, I mean, there are a lot of like obvious ones, and then in some ways there are like too many. Our problem is like there are too many. There are too
Yeah.
many. We need to be able to distill it down to like just that bucket of three things, or like three examples, I think. Um,
Yeah, I
but we'll get
think
there.
yeah, I think like what Urbit does well, I think just going back all the way back to just core promise, which is deterministic computing. Just
Yeah,
hammer on
it's
that
true.
as hard as you can. And I think like people will realize like, listen, I don't want to write software forever. Like I want to write software
Yeah,
once and make it run forever. And
yeah,
like then I can write more software or better software, right?
right.
Um
Yeah,
like
or I can go
yeah,
outside.
yeah, go outside, right? Exactly.
I mean, or just stop right now. Just do other stuff. Um,
Yeah.
all right, I don't want to take up too much of your time. I feel like we covered some really good stuff. I'm
Yeah,
excited
yeah.
to see your demo. It sounds like you guys are getting close. I was feeling like I had missed something, but it sounds, I mean, it's a hard problem,
No, no,
so
no. You're not missing out. Not, so we're like heads down. Like I was looking at my Jira board and I'm like, holy smokes, we have so many points left. We still have to
nice.
go through all of these things.
Yeah.
Speaking of which,
Well, good luck.
yeah, thank you. Uh, Thank you very much for hosting, and I don't want to take up your time as well. I know it's kind of like
Oh, that's
same.
okay.
Yeah,
No,
yeah,
what?
yeah.
Oh, I think doing these is fun, and it's a good. Yeah, I feel like it's good. It's a great. Yeah, no, it's great. I love doing this. Yeah, happy to.
Awesome.
I'm glad we could make it work out. Um, uh, let's see. So you going to the Bay anytime soon? I'm fading.